Good morning. Selamat pagi. Salam, my dear friends and colleagues. A very warm welcome. In this room today, we have a diverse gathering of talents. Among us today, we have developers, engineers, scientists, professors, strategic thinkers, leaders, and of course, my dear friends and colleagues from PM, MMU, and R&D. Joining us as an honored guest is none other than Professor John E. Fernandez and Professor Chuan. Professor John E. Fernandez, a distinguished expert in building technology from the Department of Architecture at MIT, the visionary founder and director of the MIT Urban Metabolism Group. Welcome to the Big Idea event, an event that promises to inspire, educate, propel us to ignite our minds, and pave the way for the more resilient future. At TM Research and Development, we appreciate the hard work, the teamwork that needs to come together to innovate and create breakthroughs and solutions. You all who are core to the solutions making a difference in customers, businesses, households, cities, nation. So, are you guys excited? I'm sure you are excited to learn from the best, and who better to shine the torch on the future than the stalwarts of MIT. I, Mahesh Kumar, Head of Quality Engineering. I'm thrilled to be the MC of the day. Now, as we proceed further, please join me in welcoming to the stage the Head of Business Management, the Head of Digital Innovation and Product Portfolio, an IoT specialist, digitalization enthusiastic, the WOW, Dr. Sharik Hasib.
Assalamu alaikum and good morning. I thought he was going to introduce the speaker, right? And then he says the wow, and I was like, oh, he missed me. Right? Okay. Anyways, today we have a very, very distinguished professor with us. And you must be wondering, what is the big idea? Right? What's the big idea about this talk? We have had a lot of announcements and stuff happening since morning, right? So this big idea lecture series is our inaugural series, right? The first that we are doing for this year, right? The idea here is to bring our partners, the best of the best from around the world, right? To take us to that global stage that we aspire to go, right? So I just want to share with you a personal story, right? My father is a professor of environmental law. So as a young boy, I used to help him type out his books and articles and everything. And he would have a lot of things to say to me, about how I was not so good at typing. But there was this one thing that my dad always said, and I remembered it until today. Most of the things are forgotten, right? But this one thing I remember until today. My dad used to say that this world that we live in, right, does not belong to us, right? It is something that we have borrowed from our next generation, right? And it is our responsibility to return this world to the next generation in the same state or a better state, right? So today we have the professor. He's going to show us how to return this world to the next generation in the same state, or at least in a better state. So I would like to welcome Prof on the stage. Yes, please. A little bit of introduction about the speaker today. He's a professor of building technology in Department of Architecture at MIT, founder and director of MIT Urban Metabolism Group, right? His research focus is in the resource intensity of cities and design and technology pathways for future urbanization. His professorial roles include Chair of Sustainable Urban Systems for the International Society of Industrial Ecology, Associate Editor of Journal Sustainable Cities and Society. Prof, I would pass the stage to you, and
Great, thank you so much. Very nice to be with you. First of all, thank you so much for the introductions. Thank you so much for hosting me. I have an hour with you, and my measure of success, I know I'm gonna be walking around a lot. So my measure of success is how many questions you ask and how much you talk versus me. I will present a lot of material. I've got about an hour's worth of material, but it's really important to me for you to ask questions, okay? And I'm actually gonna ask you questions from time to time as well. So let's, the title of the talk is Getting to Net Zero, How to Avoid the Worst and Create the Best Planet for All by 2050. So net zero, what is net zero? Anybody have a sense? Raise your hand. Does anybody know what net zero means? Nobody knows? You have no idea. Anybody want to volunteer? I will get you to talk. Okay. I'm going to be a nightmare for the cameraman over here. So net zero means that at some point in the future, we are capturing as much greenhouse gases somehow as we are emitting. So that on an annual basis, the atmosphere is not increasing the concentration of greenhouse gases. That's what net zero means. Please remember that. It's really key to this talk. So let me start. There's three sections in this talk. The first is I'm going to talk about what we've done to the climate. I'm going to spend not a huge amount of time on this, but it's important for us to know up-to-date information about climate change. There's a huge amount of information out there. And so I want to just boil it down to some really key points. So the climate today and soon. So to begin with, so can you see this? Yeah, okay. All right, so I'm just going to get into the real, I think I was encouraged to just get to the point, right? And give you the real message about climate change is that we're nowhere near addressing climate change. So take a look at this graph, and I think you can see those colors. So there are many projections of how we're doing with reducing carbon emissions. This is a graph of gigatons of CO2 emitted on an annual basis. And this is that very light gray line is historic emissions. So, up until 2023 or so, anybody have an idea why there's a dip right here? Yeah, COVID, exactly. So that's COVID, and after COVID, we increased our emissions. I'll talk about that in a second. And these are three scenarios that have been modeled. The first is sector by sector review of the policies, measures that are actually in place or under development. Those things that are actually being done now. Emissions are going to be reduced, but somewhere around 2010 levels, right? Not anywhere near by 2050. Remember, net zero means getting close to zero and then capturing some carbon, right? So the stated policy scenarios is not going to be a success story for us. The second, announced pledges scenario. So this is what has been announced. governments will meet in full and on time all of the climate-related commitments, goals, and targets that they have announced, including long-term net zero emissions pledges and nationally determined contributions. So the Conference of the Parties, the 28th conference that was just held in the UAE, agreements between governments, that's what this is. And the announced pledges still means that we have, 13 or so gigatons per year, which is not bad. Actually, that's getting close. Net zero emissions by 2050 scenario, okay, net zero CO2 emissions, I just said what that is, getting to zero by 2050. So this is where we actually are. This is what countries have said they will do. Historically, countries have not delivered on their commitments. So we can't depend on this scenario, and this is what we need to do. Okay, so let's take this a little further and go to what does this mean in terms of temperatures. So I'm going to show us several graphs, but I'm not going to try to overdo that because I really, really want to get to just an understanding of where we are. So, okay. So these scenarios then mean a certain amount of warming. How much warming, anthropogenic, industrial warming, human-induced warming do we have on the planet today? Any idea? 0.5 degrees Celsius, 5 degrees Celsius? Where are we right now? 2 degrees? Any other bids? 1? Yeah, so it's basically about 1.2 degrees where we are right now. Okay, so for those three scenarios that I showed you, the steps scenario will amount to at least 2.5 degrees warming and of course these are percentile ranges, maybe even 3.5. 3.5 degrees warming is a complete disaster. It's not as existential. It's not that we will go extinct. In fact, we can go to 7 degrees Celsius warming and we won't go extinct. I am not of the camp that says that we will go extinct. We're a very sticky species. Some of us are going to survive. Many won't if we have above 3.5 degrees, but we're not going to go extinct. I just want to please disagree with me if you think otherwise. The announced scenarios, maybe 2.5, but around maybe 1.8 or so. And then the net zero energy is intended to keep warming below 1.5 degrees. That's the point. That's the goal of that scenario, okay? Moving forward, then, question is, how have we done? Sorry, the question is, the clicker is kind of difficult. I'm just going to keep on. All right. So the need to get to net zero emissions, for us to get to net zero emissions, you have to have a reduction in carbon emissions of about 50% per decade. Okay, everybody with me? Okay, so 50% per decade to get down to actually about 5 gigatons. That's where we're probably going to be able to do no less than 5 gigatons. And remember, this is 5 gigatons per year in perpetuity. We're always going to be emitting about 5 gigatons because that last 5 is going to be virtually impossible for us to not to have. Agriculture still is going to emit something. There's shipping and other things still are going to emit some greenhouse gases. And then this blue line is capturing from the atmosphere. That's the amount that we take out of the atmosphere, and that gets to net zero. For us to reduce our carbon emissions down that much, we have to do it 50%. Half has to be reduced per decade. Notice that this starts at 2020, and we're still increasing our emissions. So we're not on this path, all right? Everybody with me? Any questions? Any disagreements? No? Not yet? Good, not yet. Okay, what does this mean on an annual basis? This means about 7% per year on an annual basis. So I'm just going to say, next slide. Yeah, okay, next please. I'm just going to say next for each because the clicker is really not working. So this means a 7% decrease per year. So is this achievable? Raise your hand if you think this is achievable. Come on. Okay, let me put it the other way. Raise your hand if you don't think this is achievable. That means all the rest of you think this is achievable, correct? Yes? Or are you just shy? Not sure. Okay, that's good. That's a good answer. You're not sure. Okay, this is the point. Next, please. The point of this is, how do we even know if we can do this? Well, all of us, if you could, yeah, okay. So all of us unwittingly were engaged in a global planetary experiment. If you could go back one click, just one click. The experiment that we all participated in was the pandemic. During the pandemic, aviation went almost to zero. So, large sectors really reduced their production, and lots of other things. People stopped commuting to the central business districts, right? Click twice, please. And this means that during the worst of the pandemic, there was a reduction of 5.4% in 2020. So we practically closed down the economy and we got 5.4%. So those of you who think that we can't do it, there's good reason to think that we can't do it. But the real point here is that this is not just a tweak. This is not just a slight change to your lifestyle or some kind of, commitment that a company or a government's going to make and then sort of deliver 50%. This is a huge change. For us to actually achieve 7% is an enormous thing that we need to do. And how are we going to do that? So the rest of the talk is basically on how we're going to do that. Next, not only did we have just 5.4% reduction, but when we came out of the pandemic in 2020, we had a 6% increase in carbon emissions, which was the largest percentage increase. It was also the largest absolute increase in carbon emissions of 2 billion tons, right? So we came back, a number of people, do you remember during the pandemic when there was talk of, well, the pandemic's gonna teach us. We're gonna learn how to live on this planet. We're gonna appreciate being more sustainable. We're gonna do something about climate. I was thinking the exact opposite. I was thinking when we come out of this pandemic, everybody's gonna wanna get on a plane, right? And that's exactly what happened. So next, please. So the reality today is that there's an enormous increase in emissions, and some of it now is tied more and more to increasing consumption and production in emerging economies. And here's a provocative statement for you. Maybe some people think this is provocative. Most people in the world should consume more. The reason I say that is most people in the world don't have access to a reasonable level of resources. For example, in Africa, 600 million people don't have access to reliable electricity. We should add 600 million people to the electric grid in Africa. There needs to be, potable water is another one. The enormous lack of access to potable water, which is very energy intensive. And food, caloric intake, all of these things. So there needs to be a huge increase in the level of living, standard of living across emerging economies. And that is happening. It's beginning to happen. Malaysia is a success story in this regard, but you'll see where your carbon emissions are in one moment. And so in where we are now is that the emerging economies are beginning to overtake the mature economies in the total amount of carbon dioxide emissions on an annual basis. So the future is yours. Actually, the largest decreases, the most important actions are going to happen in countries like Malaysia, who will be able to leapfrog the kind of carbon intensive production and consumption that the West has benefited from a long time. Lots of questions about equity, lots of questions about loss and demand and damage, lots of questions about that. Please ask me those questions at any point. Okay, next slide. So the result of this is, and I don't have to go into this, we've had the warmest year in history. We will continue to have the warmest year in history. Next year, the year after that, maybe not next year, but within the next 5 years, we'll have another warmest year in history, and this is just going to accelerate. Next, please. And the consequence of that is that we're now headed towards those critical thresholds, 1.5 degrees of overall average surface temperature warming in post-industrial period. And the reason this is a concern is because there are things called tipping points. The runaway phenomena, physical phenomena that are triggered, and then we can't do anything about it. We can remove carbon dioxide from the atmosphere. We actually have technology to do that. We know how to do that. We can scale that up. We could potentially even reduce the concentration of CO2 in the atmosphere. But that doesn't mean that other physical phenomena that are triggered may not be controllable, like the Amazon rainforest succeeding or converting into a savanna, drying out and converting into another biome, another kind of biome, Arctic sea ice. So today, the last few years, summer sea ice in the Arctic for many years has been reduced, and it looks like sometime in the near future, there will be zero summer sea ice in the Arctic. These things are tipping points because when you convert ice, when there's less ice on an ocean, you have that darker color ocean absorbing more heat, leading to more melting. That's a self-reinforcing loop. That's what a tipping point amounts to. The thawing of permafrost around the northern latitudes means that the permafrost is often a cap on an enormous amount of natural methane that's below that permafrost. Permafrost melts, that methane is released, that methane leads to greater warming, more permafrost melts, right? So those are the sorts of tipping points that we have to be careful of and are probably going to be triggered if we hit, and some of them may have already been triggered. Part of the reason this is I don't know if you can see this, but this is a graph that just says that for each one of these temperature thresholds, there's an exponential increase in extreme events. So for a 1 in 50 year extreme heat over land event, 1 in 50 years up until 1900 to the present 1.1 degree or 1.2 degrees, 50-year event becomes 5 times more likely. For a 1.5 becomes almost 9 times more likely than 1 in 50. For 2 degrees, it's 14 times more likely. So there's an exponential increase in the frequency and also the severity of these kinds of, next please, events. Okay, and next please. And this means that we are probably going to overshoot 1.5 degrees of warming, almost certain. In the high 90 percentiles, we know that we're probably going to. And why is, anybody have an idea of why that is a problem? Anybody from what I just said? Anybody want to offer anything? I will get you to talk. So why is 1.5 degrees? Why? How about 1.4? How about 1.45? Yeah, all sorts of things. Sea level rise, all sorts of things. The tipping points I just mentioned. The point I want to make is that 1.45 degrees is also really problematic. 1.5 is arbitrary. It's just a nice round number. We're in a, decimal system. 1.5 sounds like a thing that we should be concerned about, but 1.48 degrees is just as. So the issue is we're already in a warming scenario in which we should be concerned. Next, please. Okay, you can't see this very well, but so how do you solve for climate change? So a few things I'm really going to want you to remember from this talk. One of them is there is no solving climate change without completely transforming the energy sector. You know that. There's some relation to digital technologies that I'll get to in a little bit, because almost 3/4 of energy consumption is in the carbon emissions is from the production of energy. Okay, about 25% is from agriculture. That's very relevant to Malaysia. It says 18% here, but when you add all the other little components, it becomes about 25%. So next please, let's start talking about, let's just touch on Malaysia, and then I'm gonna go into solutions. So GHG emissions by sector per capita. Okay, keep that in mind. This slide should say per capita GHG emissions, per person. Notice where Malaysia is. Malaysia is higher per capita than China, higher than Indonesia. Actually, a significant amount higher than the world. Why is that? Anybody have any guess? Cheap oil, yes, absolutely. And cheap oil, not only in consumption, but also in production. There's a lot of production. Any other? Is oil the only thing? Urbanization, yeah, urbanization generally. One point about that is that the more money you make, the more carbon emissions you emit. There's a very tight correlation in every economy around the world. So the wealthier you become so far, the more carbon. Any others? Palm oil, yes. So I'm going to generalize that. Agriculture generally. Agriculture is a huge greenhouse gas emitter, and especially methane emitter. Okay, so there, for a variety of reasons, Malaysia has a ways to go to reduce its emissions. Notice that there was a huge uptick in the beginning of the 21st century, but it has been coming down. Why has it been coming down? Any thoughts about that? What has contributed to it coming down? Some more efficient production processes, yes, to some extent. Yeah, some commitments made by the government for afforestation, yes. Change of government policies, yeah. Others, other ideas? Digitalization, that's actually, yes, that's, I'm gonna broaden that in a second. Any others? So the service economy has grown tremendously in Malaysia. The service economy is not as materials and energy intensive as lots of other sectors. The fact that Malaysia has a significant service economy is really important and really an enormous opportunity to continue the reduction of carbon emissions. Next, please. Okay, about solutions. I know this is a lot of material. I've only been talking for, about 20 minutes. All right, so I have another 30 minutes to go or so. So the last two sections are about solutions. The first section is rapid decarbonization. So what I showed before, 50% reduction of carbon emissions down to net zero 2050, that's rapid decarbonization. It's enormously ambitious. So next slide, please. So how do we get there? This slide, I'd like you to remember these 4 points, okay? So when you talk to your friends about climate change, when you talk to your children, your colleagues, these are the 4 most important priorities. The first I've already talked about, expand clean energy sources. I don't like the phrase clean energy sources. This is from the International Energy Agency, the IEA. I'm just using their words. I think the priorities are fantastic, but I would say expand decarbonized energy sources and increase efficiency in electrified vehicles and buildings. That's the first one, because that's almost 3/4 of carbon emissions. Okay, that's the first one. Second one is eliminate deforestation by 2030. A huge priority that Malaysia has committed to is to reducing deforestation, making agriculture more efficient, and globally this is super important and just as important as the first one, because forests absorb carbon and we can't lose any more of our natural carbon sinks. The third is to reduce non-CO2 greenhouse gases. The most important, and for oil production here in Malaysia, is methane. reducing methane, and reducing fugitive emissions. Those emissions that leak from pipes, leak from storage containers, leak from oil and gas wells, or are just released by companies when they don't know what to do with the methane that comes as a byproduct from oil production, right? And then the fourth is capturing carbon from the atmosphere and storing it. You should do 1, 2, and 3 before you even think about 4. We have to do clean energy, we have to eliminate deforestation, and we have to reduce non-CO2 greenhouse gases before we move into carbon capture. And there's a lot of interest and a lot of investment in carbon capture, but it is absolutely the last resort. Next slide, please. Okay, a few things. Decarbonized energy, some positive news. Globally, decarbonized energy is expanding hugely. So global energy capacity this past year is larger than any other year. The numbers are still coming in, but it's about probably going to be the largest absolute increase ever, to more than about 440 gigawatts in 2023. And around the world, you probably know this, but around the world, renewable energy systems, photovoltaics and wind turbines, are more competitive than fossil energy. They're cheaper sources of energy. Okay, next slide, please. Yes, question.
How has intellectual property been hampered adoption?
That's a really good question. How has intellectual property? So, and I have not read, I have not spoken to anyone who's told me that intellectual property has hampered the expansion of renewable energy.
Because within the cost of us adopting these technologies means licenses. Then again, you're replacing cheaper coal, you're replacing energy. I always find this conundrum where developing countries say use renewable stuff, but it's more expensive to use renewable technology.
There's no, so there's a question about using the microphone. So there's always this question about, and I'll just repeat, there's always a question about, developing economies being told that they need to expand their renewable energy capacity, but then the payment of fees, payment of licenses and fees and technology and paying other companies, foreign companies to, build that capacity doesn't necessarily benefit your economy. That point, yes, that's absolutely a concern, that the larger companies around the world have the ability to benefit economically from expanding their capacity in different countries. That just means governments need to take that seriously and foster the generation of a reasonable amount of renewable capacity development within the country. Difficult to do, takes a long time, takes capital, but there's no way around it otherwise. So yes, I mean, to your point, yes, there are economic issues in the United States. For several decades, we've been concerned about the main supplier of photovoltaic arrays being China. And the United States has tried to start up a number of companies in producing photovoltaics with mild success. And so this is a challenge for every country. Yeah. Okay. Moving on. I'm going to leave it at that. I'm moving on. Another decarbonized energy source that I want to highlight is the emergence of and expansion of hydrogen. And hydrogen demand in 2022, likely in 2023 as well, is reaching historical highs. And there's an enormous amount of investment, private and public investment, next please, in hydrogen. For example, this is a map of low emission hydrogen production projects at various stages around the world. Hydrogen is a fantastic fuel, but it's difficult to work with because it's difficult to transport and to store. So local production and local consumption is going to be one of the more successful models for hydrogen, and that we'll see how that plays out in the next few years. Next slide, please. And that's a sampling of some of the decarbonized energy solutions. I could go on, and I'm going to show a few more, but now these are some climate solutions that are emerging. And I want to present these to you so that you get a sense of what's happening at MIT and beyond. And again, please ask me questions about these things. There are a couple of slides on digital technologies here that hopefully you will perk up when I show those slides. So climate solutions, next slide. This is the list of solutions that I'm going to highlight. The first is nuclear energy, new types of nuclear energy. Second is digital technologies, computational and AI. The third is materials, especially using materials in using AI to discover new materials, so innovation alongside AI, and low emissions materials, sometimes labeled as green chemistry. The fourth is food technologies. Again, it's super important for the Malaysian economic context. Cities and urban metabolism, that's my research area. I'll say a few words about that. And then the last area here is science-based business decision-making, and I gather your organization has recently appointed a chief sustainability officer, and so we'll talk a little bit about that. Next slide, please. So to begin with, on nuclear energy. So when people say, you know, what are the technology solutions that we need to solve climate change, there are the existing technologies, two of which I just went through, right? So renewable energy systems, photovoltaics and wind turbines and other things, and hydrogen. Those are proven technologies. We know how to do it. The economics on hydrogen need to improve for the market to adopt, but these are proven technologies. Here are some technologies that are emerging. They're being developed, and they will be hitting the market very soon. The first is nuclear, non-fission. The two examples I have are non-fission nuclear. The first is a nuclear battery, which takes advantage of the thermal energy that's produced from the continuing degradation of radioactive waste contained within a pod like this that can be shipped to different locations and serve a localized energy need, especially a high temperature industrial need for power. These nuclear batteries are being developed. There are a number of different startups. They take advantage of the need to further process nuclear waste and produce thermal energy for power, for heat and power. Next, please. The second nuclear technology that you may have heard a bit about in recent years is fusion. Fusion technologies have benefited, first of all, enormously from digital technologies, computer simulation and computational speed and power enormously. No way fusion will have gotten to this point. This is a spin-off company called Commonwealth Fusion Systems. It's an MIT spin-off, and that number is old. It's now almost $3 billion of private venture capital investing in this company over 9 rounds. And so fusion as a technology is fast developing a working prototype for distribution to the power grid, maybe in 10 to 15 years. Any questions on fusion? No? Is it safe? So there's no nuclear, so there's no the question was, is it safe? There's no radioactive waste. Why is that? Anybody know how fusion works? Somebody must know. Yeah, so fusion works. The word is there, right? Fission is the splitting of an atom, and by way then the power generated is greater than the power needed to precipitate that reaction, right? Fusion is the same, taking 2 atoms, the lightest atoms possible, hydrogen, helium, and fusing them into a heavier atom that then produces more power than it takes to fuse them, right? That's fusion. The product is a slightly heavier atom, right? So helium. I mean, that's the product. So no, it's safe in the sense that the reactor itself is not producing a radioactive waste. Of course, the system itself is super high temperature. So yes, there are safety issues regarding the super high temperature of the reaction. So fusion is a technology that is it will absolutely change the world. The question is, in 10 years, 15 years, 30 years, 40 years, we don't know. But when fusion happens at a prototyped and then market entry scalable version, we will have free energy, essentially free energy forever. This is essentially the ultimate long-term solution for climate change and for all of our energy needs. Next, please. Yeah.
Regarding the fusion, right? Can you give some indication of scale, size? How big is the infrastructure we need to power a country, for example?
How big is the
fusions,
the actual reactor?
Yeah, the reactor. Yeah.
So the systems, the labs that are developing fusion of different types, the different ways in which to fuse atoms, are working on prototypes, right? They're working on first of all, they're working on producing positive power from the reaction itself, which is just in the past couple of years has been achieved. The prototype itself, you saw, if you could go back, the prototype, MIT prototype is that size. You see what that is, right? So, but that's a laboratory prototype. That laboratory prototype is really to do all the things that we need to do to understand the physics of it, to be able to then develop powerful simulation models, to be able to improve the system. That prototype is not a workable reactor. The reactor is likely to be much, much larger and very capital intensive. It's not going to be any less capital intensive than fission reactors. So these will be large, very large power facilities, probably on the scale of a typical fission reactor, right? So that kind of size. But the powering of the country, right? So they can be different sizes, right? So a 10 megawatt, 100 megawatt, 200 megawatt depends on the scale of the actual reactor itself. Okay. Next, please. Okay, digital technologies, computation, and AI. So this is your thing, right? So globally, data centers and networks consume about 2% of the world's power. There's a range on this number, right? I've seen 1%, I've seen 5%. So it depends on how you count, it depends what method you're using, but the more reliable figures that I've seen are around 2%. And there is a real need for continuing efficiencies and decarbonization because the consumption of digital technologies is enormous and enormously accelerating on a daily basis. So there needs to be the continuing efficiencies of the delivery of digital technologies. Next, please. The positive story about digital technologies is that there has been, over the past 30 years, 10 times increase in the energy consumption, a 1 million times increase in the data traffic, and a decreasing per capita energy consumption. The digital technologies has actually decreased the carbon intensity, the energy and carbon intensity of delivering a packet of information. The reason this is that there has been the compounded efficiency of hyperscale data centers and the design and then the building and the proliferation of hyperscale data centers, which are super efficient at collecting and then exhausting heat from those servers. And the fact that we do so much on our phones. We used to do everything on large screens, on desktops. I don't use a desktop at all. Does anybody use it? I'm sure you probably do. I do everything on my laptop or my phone. Those screens, those smaller screens, are much more efficient. They're also much more material efficient, much less material required to run them. For those reasons, and next slide, please. And for those reasons, and the fact that companies have become very serious about making data centers, the whole operations of them, even more decarbonized by co-locating renewable energy plants alongside those digital technologies, the delivery of that digital service. The downside here is it's possible we may have seen already the massive energy efficiencies that we're going to get from these strategies. it's maybe possible that we're not going to see a continuing efficiency in the delivery of data and information, because hyperscale data centers can't get infinitely large, right? So there's going to be a limit on, and there already is limits. And those limits are local limits, the amount of land, the amount of investment, local community acceptance of these very large data centers. There's already in Europe major issues with local communities opposing data centers because of the noise. There's a significant amount of noise that comes from data centers. So we may have seen the end of, or we may be seeing sometime soon, the end of the enormous efficiency gains by the strategies that I just talked about, which means that your industry may see an increase in carbon emissions, for which there's going to have to be there will be growing concern. Already there's an increasing awareness of the energy and material and carbon emissions intensity of digital technologies. It's becoming better known by consumers that if I'm online, if I'm on Zoom, that's not a zero carbon strategy. There is a non-trivial amount of carbon emissions associated with that. And even though many of us like to have our video cameras on when we're on Zoom, or that opening up that video camera is 10 times the carbon emissions than not operating your video camera. So even though you're encouraged to do so in meetings, please everyone turn on the cameras, right? You've heard that before. Immediately that collection of people are consuming 10 times more energy, they're emitting 10 times more carbon emissions. So there are going to be, there's already a growing awareness, consumers are becoming aware, companies are becoming aware, and your services are going to really have to contend with and address that. Next slide, please. But the other side of digital technologies is that there's an enormous potential, still untapped potential for the use of especially AI, generative AI, for addressing some of the breakthroughs that we need to solve climate change. So in this case, I'm showing one project. This is Professor Stephanie Jajelka and Elsa Olivetti, who use AI to explore novel ways in which to process materials, fabricate materials. You know that AI has been used to discover literally tens of thousands of new proteins. You've heard of that, right? The huge breakthroughs. And AI is going to continue to deliver enormous benefits, for the climate is an untapped application of AI, generative AI still. It's still a very small niche application. So lots of good things to think about there. And you should ask me when I'm done, you should ask me, so what are the other examples of using digital technology to solve climate change? Next slide, please. Another challenge that we have, and I'm going to offer a couple of solutions, but another challenge that we have is food production. So is everyone here a Malaysian citizen? Yes, yeah, pretty much. So your country is an extraordinarily important agricultural producer. So food is, an extraordinary thing that you're delivering to the economy. It's also maybe the most pressing climate challenge that we have. To be able to produce the amount of food that will be needed by 2050 and reach net zero, maybe it's impossible. Why is that? So today, what's the population of the world? Who knows? What's that? 7? I heard 6. 8? Yeah, so it's 8.2-ish, right? Depends on what. 8.2. We passed 8 billion in 2022, I think, in November 2022. 2050, we're going to be 9.7 billion. So 20% increase in the global population. Yeah.
But Prof, isn't there a theory that says at some point the population is going to taper, i.e. will reach a critical mass and it won't go higher?
Yeah, absolutely. And there are different projections, but And in the recent years, that has been decreased. We used to think we're going to be hitting 11, 12 billion. Very few projections actually are projecting that now. So yes, there'll be a limit, but who knows what it'll be, 10.2 or so. Sometime 2100 or so, there'll be and then a decrease. Yeah, but it's pretty, the consensus today is that it's pretty solid that by 2050 we'll be somewhere around 9.7, maybe 9.5, maybe 9.9. So it's a 20% increase. If it's 18% or 22%, same argument I'm making. It's an enormous increase in the global population. To do that, we have 3 challenges. The first is that if all things being equal, business as usual, we will have to add just about 600 million hectares to the land that we use for agriculture. It's an amount of land about the size of India. We'll have to add India. Okay. We'll have to add India to the amount of land. If we do, and again, all things being equal, business as usual, if we don't add land, we're going to have a 56% caloric gap, right? So we're going to have to fill a 56% caloric gap. So why do you do that? Well, you just add land. Well, okay, is that really the right thing to do? If we were to add land, the emissions would increase by about 10 to 15 gigatons a year, right? Remember the 5 gigatons that I talked about? So in 2050, not only are we going to have to reduce the emissions that we have now, but let's add 10 to 15 gigatons per year. It makes the problem much, much more difficult. So there are several challenges here. Next slide. And digital, next please. And the digital technologies are really poised to help enormously, both on the AI side and also on monitoring of agricultural practices, the moisture level in fields, nutrient additions to fields, making agriculture much, much more efficient. If we can make agriculture 50% more efficient, we won't have to add 600 million hectares to land for agriculture. A project, another challenge is the overuse of nutrients or fertilizers for increasing productivity. That is one way to increase productivity, but there are significant local ecological environmental consequences of overuse of fertilizer. So one way to get beyond that is to bioengineer natural ways in which microbes can fix nitrogen. And that's a holy grail for food research. And Professor Ariel First at MIT's basically developing metallic organic compounds to protect bacteria that fixes nitrogen and makes that bacteria resilient so that it can actually replace or substantially reduce fertilizer for fields. Next slide, please. Another professor is working to capture the methane that's produced from livestock, from domesticated stock, from animals, in these kinds of facilities, in agricultural sheds with cows and pigs and chickens, where an enormous amount of methane is produced, to be able to capture that methane and convert it into CO2 and store that CO2. Methane, remember, is a much more powerful greenhouse gas. Converting into CO2, CO2 is still a greenhouse gas, but much less so. And then you can take that CO2 and store it. And this is a proven technology. She's actually started up a company. She's got a couple of installations in Maine. This is probably a company that's going to globalize its technology very soon. Next, please. So those are just 2 examples on food. Now the work that I do in cities and climate change. So you probably know that cities directly and indirectly control the world economy. About 80% of the economy can be attributed directly and indirectly to decisions made in cities and the consumption in cities. This is a photograph of Thailand, and the enormous increase in urbanization in this part of the world is contributing to climate change hugely. It's also a place, the cities themselves are hotspots for climate innovation, electrifying the transportation system, electrifying buildings, urban agriculture we were talking about earlier today, and other systems that can really completely change the way that we produce and consume the things that we need. The work that I do in the urban metabolism group is part of cities, the physical resources, materials, energy, water, and other things, food, how that serves a population, develop metrics of efficiency, and then provide pathways for sustainability for future urbanization. This is extremely important today. You might know that in the next 30 years, the urban population is going to double. We're going to, of all the cities that we have today, of all that urban form, we will have double that urban form in 30 years. That's kind of an astounding thought. The urban population in Africa is going to exceed 1 billion, probably 1 billion people. Lagos, Nigeria, has anyone been to Lagos? No? Is projected to be a city of 90 billion people, 90 billion people in 100. It's kind of it's hard to imagine what that looks like, especially in light of the fact that Lagos today can't really deliver the resources to all of its residents. So what's a 90 million person city going to look like? Next slide. So there are huge challenges in cities. And then finally, I want to end with a couple of slides on the business aspect of sustainability and environment, social, and governance issues associated with the way that companies run. So have you heard of ESG? Raise your hand if you've heard of ESG. It's kind of in the water, right? So you kind of know. All right, so ESG is the dominant framework in which companies are measured on the way in which they are behaving in the environment, on social issues and governance. It is important to be extremely skeptical of ESG. ESG has been used to improve the reputation of large corporations that may not be doing much in environment, social, and governance. However, the framework itself is not to blame. It's the people using it that are to blame for the misuse of environment, social, and governance, measuring the behavior of companies. So there needs to be an improvement in the way that we use these metrics. Next slide. And a professor at the Sloan School of Management at MIT noted this. He noted that today there are half a dozen companies that rate other companies on their ESG progress and how they're doing. They have their metrics, and they will rank a company in terms of how good or bad it is behaving across ESG. Each one of those 6 ranking companies has a different method for arriving at that ranking. So up until recently, these companies are saying different things about the same company because they're using different metrics, different methods. So it's confusion. It's not useful. That's part of the reason ESG has been misused. So this professor, Roberto Rigobon, in the Sloan School of Management started a project called the Aggregate Confusion Project to be able to cut through this confusion. And the most important thing he did was to get in touch with all of those ranking companies and say, look, in a pre-competitive space, let's come together and see if there's a possibility of harmonizing the metrics you use to rank companies on their ESG performance. And he's been doing that. The project's almost finished. And moving forward, there will be a much better framework for ESG. So ESG is not something to dismiss. It has been misused, but it's improving, and it's really, really important that companies participate. Next slide. Another development in the business world is the now emergence of the chief sustainability officer or some similar person in a company. So I talk to probably 1 company a week now on average. Most of those discussions are on Zoom. Most of them are at C-suite level, and more there's a chief sustainability officer attending my talks and my seminars. The chief sustainability officer used to be a person who was in charge of environmental compliance of the company, making sure that the company was not breaking local environmental laws. Now the CSO is actually a strategy person because the CEO knows that the most important challenges and business opportunities in the future are going to come by way of climate change and sustainability generally, and associated issues like biodiversity loss. So the CSO has become a central person in organizations, and I gather, again, like I said before, you have one here. One of the decisions, last slide, next please, is that the CSO needs to make decisions about major efforts that the company will take to reduce their carbon emissions, like whether or not to purchase carbon offsets. Raise your hand if you've heard of a carbon offset. Do you know what it is? Can you say? But what does it mean? What do I do? Yeah, but what do they do? What's the offset actually do? Yeah, so the point, yeah, what you're saying is that it's a method, it's a strategy to use when companies want to reduce their carbon emissions. Yes, what the company does, or what any organization does, is that I feel like I can't reduce my carbon emissions any longer. I've done everything I can. Here's a company over here that could reduce their carbon emissions, but they don't have the resources to do it. They don't have the money, right? So I'm going to pay them to reduce their carbon emissions, and the carbon emissions that they reduce, I'm going to count as part of my carbon emissions. That's fair. If that organization were not going to reduce their carbon emissions, they didn't have the resources, and I came in and I paid them, then that's fair that I can count it towards my carbon emissions. So am I. So let me go ahead and say a few words before you. Okay, carbon offsets. I think many more of you than raised your hands probably have heard of them. Carbon offsets have not delivered almost any of the carbon emissions reductions that were purchased. Let me put that in some concrete terms. So upwards of 95 to 97% of carbon credits that have been purchased have resulted in 0 carbon emissions reductions. This is by way of a number of research projects, a lot of attention paid to the carbon market in the last few years, and also the admission of CEOs that I've directly talked to of these carbon credit companies. The carbon market has been extraordinarily dysfunctional, and this is another thing that I'd like you all to remember, okay? The last thing, okay? AVID, is a way to think about carbon offsets. A carbon offset needs to be another company that I'm going to pay to reduce their carbon emissions was already going to reduce their carbon emissions, then I can't count those carbon emissions towards my organization. They were going to do it anyway. It's only a carbon offset, a proper carbon offset, if it's additional. If they could not reduce their carbon emissions, they don't have the resources, and I came in and paid them, and then they reduce their carbon. Okay, it has to be additional. Almost everywhere in the world today, renewable energy projects are going to happen anyway because the economics benefits investment in renewable energy. So much of so renewable energy is likely not to be a reasonable target for purchasing carbon offsets in the future. And there are 2 types of carbon offsets, 2 types of actions that are taken, mostly 2 types, to reduce carbon emissions from carbon offsets. The first is renewable energy, and the second is afforestation, or the avoidance of deforestation. Okay? Those 2 are what are paid for. That's what that other company is doing. Either they're expanding renewable energy capacity, or they're afforesting or not to deforesting. So A is additional. V is it needs to be verifiable. If I pay you to reduce your carbon emissions, you say, yes, I'll do that. I have to come back and verify, or it has to be verified, and verified over time. Okay. The third is I, AVI, immediate. It has to be immediate. If I'm going to count that carbon emissions reductions on my books this year, that carbon emissions needs to happen this year. Carbon emissions reductions needs to happen this year, right? That's I. And then D, durable. If I pay a company to plant trees on 1,000 hectares that has no trees, and they do that, and then in 3 years, they cut down all those trees, and they use those trees for wood pellets for fuel. That's not a reasonable carbon. And that's one of the main reasons carbon offsets have been basically garbage in the marketplace. So AVID is a good way to think about carbon offsets, and similar to ESG, it's been a highly problematic mechanism. There's a lot of attention being paid to it now. A lot of startup companies starting fresh, new technologies such as satellite systems and sensors to be able to actually image carbon and methane emissions around the globe that we didn't have just a couple of years ago. And these things are extremely important to improve the performance of carbon offsets for companies. So it will get better. It will get much, much better and can be a reasonable strategy, but today it's not. I would absolutely recommend that the absolute last thing you do is think about carbon offsets. Try to do everything first, and then the carbon offset market is maybe possible. And last slide. I think the last slide. And so I'm just going to tell you to click. Please click. So some concluding thoughts. The first, click, please. The first thought is many climate futures are emerging. So we know there is no single climate future. Different companies, different countries are going to have different climate futures based on their own priorities, their own challenges. The second is development. Remember I said most people or many people in the world need to consume more. Development is essential for sustained and equitable decarbonization. We can't think of decarbonizing as slowing or reversing development. That would be absolutely the wrong thing. The third is urgent actions are needed both for climate change and reducing biodiversity loss. I have alluded to biodiversity just a little bit, but in my opinion, biodiversity loss is equally critical as a global challenge to climate change. The next, please, click. And integrated technology and policy breakthroughs. So someone asked a question about government. I talked about technologies. The two together, coupled together in an intelligent way is absolutely critical for a complete climate solution set. And finally, the last, click, please. Yes. It's super important on ESG and carbon offsets. This was the implication of what I was saying. It's coupling the latest science, a deep first principles understanding of mechanisms like carbon offsets to business decisions is fundamentally important for us to actually achieve our goals. Thank you so much.
Thank you, Prof. I will help moderate this session. So the floor is going to be open to everybody. Let's take this opportunity and learn a lot more from the learned professor, because he has experience, he has seen the tech, he has seen the implementations, right? I'll get the ball rolling. And Prof, there was one of your slides, the early ones, you know, the curves on reduction of carbon. I just can't help but wonder, you know, there are countries, they 2050 is their target, Malaysia is 2050, China 2060, India 2070, right? And by looking at the policy versus you know, holding people accountable, I can't help but wonder whether these countries are really pushing the can down the road, you know, to decarbonization, because the challenge is reduction as well as reducing the emission, right? And that is like a double-edged sword. So, Prof, over to you.
So a couple things. One is that, as I showed in one of my slides, emerging economies are quickly overtaking the mature economies in terms of the overall carbon emissions. It's not acceptable for the developed mature economies to hold emerging economies to account in the same way that those mature economies are holding themselves to account. In other words, again, like I said, emerging economies need to develop. So emerging, we need to make sure that there isn't a tempering of the equitable development in those countries, which just means we need to couple the science to the government policy decision-making. It may be perfectly reasonable for some countries to have a carbon emissions goal net zero beyond 2050. If in aggregate, and remember that net zero number is a global number, in aggregate, we are reaching net zero by 2050 in aggregate. That means some countries are meeting their goals before. It's in my opinion, it's a responsibility of the mature economies to reach net zero well before 2050. I think that's one of our major contributions. And then allowing for there to be the understanding that development may take some countries beyond 2050. So I'm not super concerned with India stating that. The other thing to just keep in mind, whenever you, I'm sure you're all well aware of this, whenever you have a country stating a goal like this, there's a whole lot more there than just the science. It's the political posturing, it's the power dynamics, it's just the development world, it's the negotiations on debt that those countries have. I mean, many things are coming into play. And so I don't take those pronouncements very seriously. It's really more what just happened this past year in that country. Right. What's the trajectory that they're on are the numbers that I'm really looking at. But again, I just wanted to emphasize that an equitable movement or an equitable solution of our climate challenge means that developing economies or emerging economies, prefer saying emerging economies, have the ability to actually develop in the way that they are best positioned to do so. In Malaysia, I would say hyper-efficient agriculture is one thing, a service sector that does continue to prosper and diversify in, and then manufacturing and industry that takes advantage of the low temperature, so the new green chemistry to reduce the energy and carbon emissions of heavy industry, and the introduction of new fuels like hydrogen.
And it's the manufacturing industry is what I'm worried about, Prof, because the thought process for a manufacturer would be, I'm producing, but the one consuming, especially for an export country like China, India, and even Malaysia to some aspect on the electronic side, right? The thought process will be, I'm producing, you're consuming. And hence, the responsibility to become net zero should be on the consumer rather than the producer of the goods. And I mean, this is a mindset, right? Because what we say is the developed economies have taken their time and released carbon to the atmosphere, while it's now our turn to do. So I mean, how's that balance we strike, Prof, in this?
Yeah. So I'm interested in your opinions, actually. Yes. But a couple things. One, it is very much. So let me put it this way. It's very much a coupled responsibility, producer and consumer. And in fact, in many cases, the consumer is the less contributor to moving a climate positive future. Because, so for example, when you walk into this room and you turn on the lights, are you making a decision on carbon intensity of the provision of the lighting? Sorry, I don't know what I'm doing, but you're not making a decision because you don't have a decision. You don't have two light switches, decarbonized and carbonized, right? You just have a light switch. So that's the required systemic change that needs to happen. The electricity grid, the fuel mix powering the production of electricity and feeding lighting systems is beyond your control. And many sectors of the economy are like that. And there are some pressures now. And so not to get into the weeds, but the way to think about it is scope 1, 2, and 3 emissions. Has anyone ever heard of that? Yeah, okay. Scope 1 emissions are emissions from the energy produced from a system that I own. So if I'm burning diesel here on campus on this, that's my responsibility not to do that or decarbonize that. Scope 2 is the energy that I'm purchasing from another, right? Scope 3 is everything else, upstream and downstream. My suppliers, my business travel, your business travel, commuting, everything else. And scope 3 is the most difficult to address. Scope 3 includes the consumers. It includes consumer behavior. But before you get to scope 3, you really have to address 1 and 2. So generally speaking, yes, you can make some sustainability choices. But I'll say one other thing, which is, you can disagree with. Much of the rhetoric around the world on the consumer being responsible for climate change is a explicit strategy of fossil energy companies to make you feel like you're the problem. I don't know if anyone agrees here or not, but it's documented that fossil energy companies and, Western, European, and American have actually enabled their marketing departments to make sure that the consumer knows that, look, we can't do anything about it. You want to drive your car. We're just providing you with a gasoline. It's your choice to make. So that we just have to keep in mind, because the fossil energy companies, and I'm super pro industry. I mean, I'm here with the Industrial Liaison Program by MIT. I'm here because I think the key is that the private sector has to be our partners in this. But that doesn't mean that you can't acknowledge that some parts of industry are going to push back to the death while we try to decarbonize. So just keeping that in mind. Sorry, I kind of went off on a tangent.
Thank you, Prof. Any questions from the floor?
Yeah, Prof. Just now you showed the graph. You said, and you asked us why Malaysia, drop in emission and then suddenly rise. And you
For Malaysia.
Yeah, it's due to the service economy and stuff.
Partly.
And if you see Singapore got the trend is a bit the same, but then it goes down and goes on all around. And Singapore is a service country, isn't it? No agriculture. So what happened to Singapore in this case?
Well, so Singapore also has enormous oil refining within their economy, and huge industry, manufacturing and shipping. So that's part of it as well. So, but the reduction has been through efficiencies. So transportation. So for example, one efficiency which is really delivered pretty significant carbon emissions reductions in the last 7 years is they have it's called congestion pricing, but they call it something else. It's I forget what they call it, but basically incentivizing, first of all, the reduction of single occupancy automobile travel in Singapore. They have an excellent mass transit system, so that pushing people to the mass transit system, and also then pricing the coming into the city for at different rates, so that even if you have a car, your discretionary trip, you limit your discretionary trips, and it has had an effect, and that is social engineering. That's engineering human behavior, but using technology to do that, because every vehicle has a sensor and they're all monitored, and Singapore also has the very onerous fee to be paid to own a vehicle. That's also helped a lot. So that sort of thing, efficiency is huge. Efficiency gains have been huge in Singapore. So yeah, that's part of my answer. But keep in mind that Singapore is also really heavily industrialized, especially oil refining. Yes.
Hello. Okay, looking at that particular slide, I just wonder, because this might be from one perspective. Do you have data which shows the total carbon contribution for each country, and how is Malaysia compared to the rest of the world? Because you see on the map,
yeah,
Malaysia is very minuscule.
Oh yeah. I mean,
I just wonder whether we are the most contributor.
Well, so yeah, of course. I mean, I'm I'm showing the slide to be provocative, right? And to sort of, yes, absolutely. There's no question about that. And per capita, you know, if I had the United States on here, the United States wouldn't even fall within, it would fall outside of the graph, right? So yeah, absolutely. But the other reason I showed it was to, you know, it's more important the trends for me. So see the trend in China, right? The trend in China has been really decidedly positive slope for quite some time, and really gaining momentum beginning in the 21st century, in the year 2000. It's interesting. Malaysia has an interesting profile where it was very high in the 1990s and has come down. And so part of what I wanted to suggest to you is that if we did graphs for lots of different countries, you would see basically 3 different types of curve. You'd see what Malaysia and Indonesia have, which is the huge rise in the 90s, early 2000s, late 90s, and then a drop, which is a very positive message. And for Malaysia, like I said before, part of the reason that is the growth of the service economy and other things. The other is that you'll see graphs like China. So China, so there are a number of African countries now that are beginning to exhibit that curve, where it's going to be a very steady increase. And then you see lots of countries that are flat, or for at least 2 decades, negative slope. And the flat ones are interesting. Sorry. The flat ones are interesting, like India, because if you read in the literature, the economic assessment of China versus India is that India is not as successful as China. It's just not, both of them started kind of in the same place back in the 1970s, you know, with, you know, obviously different resource bases and everything. But the fact that China, with a centralized decision-making economy and other factors, was really able to develop and increase, and this is just a proxy for income, right? So China's, whereas India stayed relatively flat. And many economists would look at this per capita GHG emissions for India as a failure. And actually, it probably is a sign, and in fact, I know it is a sign, that the economy has not fulfilled the promise that it had in the 1970s. So, so that's one of the other reasons I want to present this, is that Malaysia has this interesting maximum in the end of the 20th century, which a number of emerging economies, some of the more interesting are like Vietnam, also has this kind of profile, and others. And just by the way, in terms of data, there is a fantastic site that's very high quality that a lot of my colleagues use, called Our World in Data. Has anybody ever gone to that site? If you haven't, just do Google search Our World in Data, and you'll see there's information for every country in the world on carbon emissions. But yes, part of the reason was to be provocative, but maybe the more important reason is to say it's a really interesting curve. In the last few years, we've seen reduction, and I suspect that negative slope for Malaysia is going to continue, and probably can get much more pronounced. I'll leave it at that. I don't know if I answered your question.
Interesting. Hello, hi, Prof. A quick one. How do you respond to this notion that I have that, I mean, it's easier to, I want to ask about the carbon offset market, and it's easier to explain to the engineers and techies and most companies from the financial motives and financial motivation, how they can, you know, get financial gains from playing in or contributing towards carbon emission reduction. Is there a correlation between the graphs that we see here and the country's adoption of an exchange market? GHG exchange market?
No. I mean, not in these curves, and it's pretty clear that the carbon exchange market has not had a discernible effect on the overall national carbon emissions, the carbon emissions from any country. That's part of what I was saying before. There hasn't been the return on the reductions that have been purchased. So the answer is basically no. There is no signal in the data telling us that the carbon market has actually had an effect. Now, that's not the case for some regions. So the New England has a multi-state agreement on carbon market. And at the state level, Massachusetts, Connecticut, Maine, there is a statistically significant reduction in emissions that you can attribute to the market. And then there are the EU market, you can make an argument that market has had a discernible effect. There's been a discernible effect at a regional, multi-state level. Yes, you can. But individual countries, there's some countries, so like Sweden has made the point that they have decoupled from. So Sweden has made the point that they are one of the only countries that has decoupled their economy. Decoupling means they've decoupled the production of wealth from the material and energy intensity that's required to produce that wealth. And they made this point a few years ago, and other researchers took a look at that. And it's true that within the country, within production, so if you just take the carbon emissions this goes back to the point of rich countries versus, if you take the carbon emissions just attributable to production within the country, Sweden has reduced its carbon emissions while still increasing wealth production, right? But if you take into account the consumption attributable to that population, all of the things that they purchase that are imported, and the carbon emissions associated with those things, then there's no way, they have absolutely not decoupled their economy from carbon emissions. So it's really important to look at consumption alongside production. And when you look at both of those, there's no country that's been able to decouple its economy.
Hi, Prof. Considering the urgency to achieve this net zero emissions, in your opinion, what are the specific steps that a company, example like TMR&D, can take to achieve this goal?
Yeah. So so I've given a series of seminars to Accenture on the carbon intensity of the digital world, and so the most important thing is the many steps to make more efficient the delivery of your product. So algorithms, more efficient algorithms, especially in AI, more efficient hardware, so, you can make the argument that a successful quantum computer will be maybe the best thing that will happen to the digital sector in relation to carbon emissions, right? Because just the efficiency of computation. But then also efficiency at the macro scale, like I was saying before, the buildings, the infrastructure, but also the architecture of the delivery of digital products. So edge computing. So probably one of the next efficiency gains is going to be to reduce the number of servers in data centers, because you're distributing that computation to the devices and the locations. So the idea of edge computing really taking off and scaling up is an important development. So yeah, those are the main ones that I usually cite. Okay.
Hi, Prof. One question. Just now you showed the main target of the net zero by 2020 actually
By 2050.
2050 actually just to gradually decrease the carbon. But when you set the target 2050, usually people have two trajectories, whether to achieve it through exponentially decrease or parabolically decrease, right? So now that ideally is should decrease gradually. But for certain company that claim the commitment towards net zero 2050, for example, they still produce and emit the carbon because they see, yeah, I can always reduce at the end. Like, I mean, as a student, I'm what do you call average student. When I'm about to go for exam, only the last day I prepare myself to go, right? Not gradually, right? So some more with the carbon offset, and the company like BP, for example, they can always populate, what do you call polluting the environment. At the same time, they can buy offsetting the carbon, right? So is there any rules, efficient rules to enforce the government or the organization towards net zero 2050? Thank you.
Actual rules, in other words, binding enforcement, no. The answer to your question is no. But there were lots of different parts to your question. There was real wisdom in your question, if you don't mind me saying, because actually, and I'm just going to use this to make a point that I didn't have time for. Actually, so if you could actually go to the next slide, the one with the, I think the graph you're talking about. Yeah, that one, right? Actually, yeah, no question. So we're at 2020. It's still going up. It's not going to come down for at least a few years. The best projections are, maybe 5 years we'll see a zero slope to enormously high carbon emissions. Let's keep it that way, right? It'll be somewhere up here. But what I like about the way you asked your question was, yes, it's absolutely not going to be this nice, smooth curve down. What it's actually going to be is we're going to hit some sort of high, and it's going to be a bumpy road down, right? And that bumpy road down, I am very optimistic. I was in a room with, I gave a talk to 120 people the other day, and I asked, who's optimistic about us being able to reach net zero in 2050? Nobody raised their hand. I'm the only one who raised my hand. I actually think we will actually do this, but it will be by way of, first, really intelligent policy and keeping to commitments, and that's probably going to be the hardest thing. The second is technology breakthroughs. So it could be that let's say in 15 years, 2035, fusion is really scaled up. And that's optimistic, but it might happen. We might have in the 5 years after that a 25% reduction in carbon emissions or a 30% reduction in global carbon. That's possible. It could happen. So I think what's going to happen is we're going to have a series of technology breakthroughs, and being optimistic means that, and I'm very much part of a crowd at MIT, means that there will be energy put into making those technology breakthroughs happen. And those technology breakthroughs are super important for reaching net zero. There are lots of other parts to your question that I wanted to get to, but I just wanted to focus in on that one because I do think that no, there's no binding, enforcement. There are no rules and there's no enforcement yet. But technology breakthroughs and policy breakthroughs, I do think will take us there. There's one other thing. It's a little bit of a sober point, but I do think it's worth saying, is that the motivation for us to get very, very real, it's kind of like before you're taking an exam, right? If you haven't studied for the week and then all of a sudden the exam is tomorrow, the motivation is the urgency. I have to study. And it's a similar thing, I think. We will hopefully not see too many, but we will almost certainly see some massive disasters in the next 10 years. Those disasters will motivate us to really take it seriously and to move forward in an optimistic way, accelerated to solve this thing. So I'll leave it at that. Thanks. I think we've gone
Thank you,
over.
Professor. Thank you very much for knowledge sharing. Yeah, one question. Okay, we'll take this is
I'll
the
be
last
quick.
question.
Yeah.
Okay, you mentioned the tipping points on GHG, increase in the cyclical impact of that. Based on your climate solutions, can we also expect that would be some tipping points that would just suddenly, I can start using plastic straws, because the tipping point would have hit, and and the solutions would be so generative.
So the tipping points would be motivation for
Yes.
us to,
Yeah.
yeah,
No,
absolutely.
no. The solutions would just,
Oh, I
yeah,
see. I
just
see.
like how the internet
we,
just,
we
you
would
know,
have a
yeah.
solutions tipping point.
Yes, exactly.
Well, so again, yes, what happens with what, so let me give an example. I'm not going to get the dates right, but the case study is, in the mid 19th century, the fifth largest industry in the United States was whale oil, right? The oil from whales, and used for lighting, used for, used as a fuel. And then electricity was invented, and within 12 years from when electricity was invented, was mastered in the lab, to 12 years later, that industry went to zero. It only took 12 years for a massive energy system to be wiped away because of a technology breakthrough. And so your point about tipping points, or maybe the sort of the exponential adoption of technology breakthroughs, absolutely. We've seen many examples of that. Digital technologies alone is an example of that. So yes, that is very possible. And the example that I gave of fusion, I actually think that hydrogen is also an example of that. Hydrogen, once it's scaled up, will also have that kind of dynamic of accelerated acceptance. Yes, that's a good point. Thank you.
Thank you, Doctor. Thank you, Professor. It was really a nice knowledge sharing session experience. You have taken this big idea event to the next level. Thank you very much. And a round of applause to our leader, Dr. Sharik Hasib. My. We have with us our leader, our torchbearer, our CEO, the achiever, the believer, the creator, the innovator, the researcher, Dr. Sharlin Tyagaraja. May I have you on stage, please?
I'm so sorry I'm late. I had to come from another event, but thank you so much, Prof. Fernández, Prof. Chuan. It's good to see you again for coming and speaking to us. I hope you guys have learned a lot. Yeah? Yeah. I mean, we always want to emulate the MITs of the world, and we are so honored to have you here to speak to us. Yeah. So thank you so much. Shari, anything? Last words? Yeah? Yeah. Thanks.
As we move on to the next session, Doc, we would like you to be on stage because we would like to give a token of appreciation to Professor John Fernández and Prof. Followed by a photo op session. Let's capture these memories. I request the management team to please come over for a photo session.
I think now,
With the whole team. The audience. Yep.
Thank you, Professor John F. Fernandez, Professor Chuan, Wagga TM, my colleagues from TM, MMU, from Madi, Frim, and Jabatan Pehelitan. Thank you very much for attending this session and taking this event, the big idea, to the next level.
Angels sent from up above. You know you make my world light up. When I was down, when I was hurt, you came to